regarding tangent 2 theta, of course, it goes without saying that's sine of 2 theta over cosine of 2 theta. And sine of 2 theta is 2 sine theta cosine theta. Cosine 2 theta, one of the ways we've worked that out is to say that's cosine squared theta minus sine squared theta. This is only one of two possible ways to work this out, I should mention. Now, knowing that there has to be a 1 here as part of the formula, that would give me a clue that I could multiply by 1 over cosine squared theta divided by itself, in which case you can see my numerator here would be the cosine. One of these cosines would cancel with this one, so we'd have 2 sine over cosine theta. See it? And this distributing over to this would give us a 1. This distributing to the sine squared would give us sine squared theta over cosine squared theta, which is also known as tangent squared theta. There's another option for this. If you recall the formula for tangent alpha plus beta, that would be tangent alpha plus tangent beta divided by 1 minus tangent alpha times tangent beta. And so just replacing theta for both alpha and beta, you could get that as well. So there's another option for deriving this formula, and this would be the double angle formula for tangent theta. Okay, true or false? Sine of 2 theta equals 2 times the sine of theta. Stop and think about that. Now resuming from the pause. It looks good, doesn't it? It looks like it would be correct. However, it isn't. As a matter of fact, it's hardly ever correct. But we could actually solve that equation. As an example, let's do that. When the sine of 2 theta equal 2 times sine theta on the interval from 0 to 2 pi. And so if we replace our sine of 2 theta as we should with 2 sine theta cosine theta, we have 2 sine theta cosine theta equals 2 sine theta. If we subtracted 2 sine theta from both sides, maybe I should have another step in here. It would make it easier for you to see. Oops, I didn't mean for it to be like that. There, that's what I wanted to say. And this, of course, is equal to 0, right? Now, factoring out the 2 sine theta, I think it's easier to see now what happened here. We've got 2 sine theta times cosine theta minus 1 equals 0. So if we factored out the 2 sine theta, we still have a 1 there. And so that tells us one of two things. Either sine theta equals 0, so so theta would be 0, or cosine theta equals 1. So that gives us actually two choices. Sine of theta could be 0 at 0 or at pi. Cosine theta equals 1 at 0. That's the only place on this interval. 2 pi is not considered part of the interval since it's a round bracket there. And so the only place where this is true is at 0 and at pi. So everywhere else, sine of 2 theta does not equal 2 sine of theta. Here's another example problem. If cosine of alpha is equal to 12/13, find cosine of 2 alpha, sine of 2 alpha, and tangent of 2 alpha. Of course, it goes without saying if we get sine and cosine, tangent will be real easy because it'll just be sine of 2 alpha over cosine of 2 alpha. But how do we find cosine of 2 alpha and sine of 2 alpha? Pause here for a second, think about it, and see what you can come up with. Resuming from the pause, you might be able to say, well, why don't we use these formulas that we just developed to find cosine of 2 alpha? And of course, cosine of 2 alpha is cosine squared alpha minus sine squared alpha. Or another way we could do it would be 2 cosine squared alpha minus 1. But since I already have this nice drawing here, we could fill out cosine squared alpha, of course, is just 144 over 169. Sine squared is a different story. Whether we're in the first or the fourth quadrant where cosine would be positive, we would have a triangle that looked like this, or maybe this 13 would be down here if it was in the fourth quadrant. But nonetheless, by the Pythagorean theorem, this side over here is either 5 or negative 5, and we're going to square it even if it's negative. And so 5/13 would be the sine of this angle, alpha. Sorry, I have it written as theta. I should have written it as an alpha. I'm not going to fix that now, but so that would make this sine squared is 5/13 squared, so we'd have 144 169ths minus 25 169ths, which gives us 119 169ths. So there's our formula for cosine of 2 alpha. And once we know that, it should be easy for us to determine sine of 2 alpha. So that's 2 sine alpha cosine alpha, that's 2 times 5/13 times 12/13, which is 120 over 69. And that means tangent of 2 alpha is 120 over 119. Okay, you can see why that works out pretty nicely. Technically, I have a little bit of a problem here in that this could possibly have been 5/13. So in my problem up here somewhere I should have stated that alpha is in quadrant 1, right? Because otherwise I would have a little bit of a difficulty here. This sine of 2 alpha could possibly be negative 5/13. So since I said it was 5/13, then I can go ahead and without any problems say the tangent of 2 alpha is positive 120 over 119. If I would have said this was in quadrant 4, cosine of 2 alpha would be the same. However, sine of 2 alpha would be negative 120 over 169, and tangent of 2 alpha would be negative 120 over 119. Here's another example that's similar. If the sine of theta is negative 4/5 and theta is in quadrant 4, find sine of 2 theta, cosine of 2 theta, and tangent of 2 theta, and get the quadrant for 2 theta. That's different. Well, if the sine of theta is negative 4/5, then the reference triangle must be similar to this one. This side would be 3, that's the square root of 25 minus 16, square root of 9, so 3 here on this side. And so the sine of 2 theta is 2 sine theta cosine theta, that's 2 times negative 4/5 plus 3/5. Hopefully you can see why it's positive 3/5. Think about something in the fourth quadrant, the x coordinate is positive. And so hence the sine of 2 theta is just 2 times negative 4/5 times 3/5, which is negative 24/25. Cosine of 2 theta in a similar fashion is cosine squared theta minus sine squared theta, that's 9/25 minus 16/25, so negative 7/25. And here we are with sine and cosine both negative, so that should tell us we must be in the third quadrant. And notice also the tangent of 2 theta is a negative over negative, so 24/7. And the only places where tangent is positive are in the first and third quadrant, so whatever, 2 theta has to be in the third quadrant, and there's all